Everybody knows what happens in an accident if you don't wear a seatbelt. What you see in this accident looks really painful in slow motion. Modern seatbelts are not just mechanisms which arrest your motion. Rather, they cleverly allow enough movement to minimize internal injuries and help you land safely on an airbag. In this video, we won't just learn the working of a seatbelt, we will learn why modern seatbelt mechanisms are designed the way they are. So, buckle your seatbelt and let's start a design journey. Let's start with the simplest form of seatbelt design, a design using a spiral spring and seatbelt webbing. The center of the spiral spring is connected to a freely rotating shaft. You can see how the spring tenses as you rotate the shaft. The webbing is also connected to the shaft. When not in use, the passenger lets the webbing go, and due to the tension of the spring, the webbing will wind automatically. We have just built a basic seatbelt retractor. Using this arrangement, we can build a 3-point seatbelt mechanism. In this design, the other end of the webbing is fixed as shown. A buckle clip is also kept in the webbing. As illustrated, the passenger can easily buckle the seatbelt, it will fit nicely. The retractor will release sufficient length of webbing depending upon the passenger size. The 3 points in this design are marked here. This design will not cause any passenger discomfort by restricting movement. Obviously, this seatbelt design will fail completely in an accident because it allows the passenger movement even during an accident. An ideal seatbelt mechanism should block the passenger's movement in an accident. Let's see how to convert the current design into an intelligent seatbelt mechanism. During an accident, the vehicle experiences a huge deceleration or suddenly comes to a halt. A clever mechanism can be designed by making use of this effect, using this free-to-roll steel ball and a hinge. The ball is placed at the other side of the retractor, and a sprocket is connected to the retractor shaft. This means that whenever the belt winds or unwinds, the sprocket will spin. Under normal driving conditions, the ball is in a resting position, as shown. However, when the vehicle stops suddenly, the ball moves forward due to its inertia. This movement will move the hinge and trigger a locking mechanism. This locking will prevent any further release of the webbing from the retractor, which means the seatbelt simply arrests your motion during a crash. In the early days of seatbelt development, it was quite important to win people's trust so that they would use seatbelts regularly. The ball movement technology we just discussed is a perfect one, but a common man cannot test this mechanism. So, engineers came up with an interesting idea. Develop one more mechanism which is based on the webbing's speed. If the webbing moves fast, it should lock. If not, it shouldn't lock at all. This speed-based locking mechanism can be achieved with the help of a few new components. First, a central piece is fitted to the webbing shaft, and an internal gear is fixed by attaching it to the frame. Another piece sits over the central piece. Let's give it an orange color. The interesting thing is that the orange piece is not tightly fitted to the central piece. It is slightly loose and free to move, as shown. If the central piece rotates slowly, the orange piece will be able to move with it. However, when the central piece rotates fast, the orange piece won't be able to catch up with it, resulting in an interesting lock, as shown. Let's watch the same animation in ultra-slow motion for better understanding. Obviously, the belt will lock when the passenger moves forward fast. Most importantly, this is an easy mechanism that everybody can test, which increases consumer confidence in seatbelt usage. This second mechanism has another use. If the first mechanism fails, it will act as a backup mechanism. But the issues related to seatbelt design are not fully resolved yet. For instance, if the seatbelt blocks passenger movement completely during an accident, the belt will create tremendous pressure on the passenger's chest, which can lead to internal organ injury. This risk is why modern seatbelt retractors come with a torsion bar. The torsion bar helps to release the belt a little when it reaches a critical load, thus saving the passenger from excessive pressure on the chest. Let's see how it is done practically. The end of the seatbelt webbing can be connected to this torsion bar. The concept of this mechanism is simple. When the load on the belt reaches a critical limit, the bar will undergo torsion, as shown. Please note that one end of the shaft is fixed due to the locking mechanism. Note here that the twist of this bar is not uniform throughout its length. It is 0 at one end and maximum at the other end. If we connect the belt directly to this shaft, we won't get a belt release. To overcome this issue, the belt webbing is connected to a spindle, and the spindle is connected to the free end of the torsion bar. This connection means that during torsion, the whole spindle will turn the maximum twist angle of the torsion bar. This unit replaces the normal shaft of the retractor. This way, the belt will be released a little when the belt pressure reaches a critical value, which saves the passenger from internal organ injury. One more ingenious safety mechanism common in cars nowadays is the pre-tensioner. Most of us sit in a car in a relaxed way, so our bodies may not lean on the seat perfectly. This posture drastically reduces the amount of time the safety mechanisms have to save your life. However, a pre-tensioner makes you sit as close to the seat as possible right before an accident. Right before impact, most of us press the brake pedal hard. A smart controller predicts an accident by sensing the fast movement of the brake pedal. The retractors with pre-tensioners have an additional piston mechanism. A piston mechanism filled with explosive materials. As soon as the controller detects the chance of an accident, it will ignite the explosive, which will push the piston and the seatbelt will tighten. In short, even before you hit the rock, you will be ready for the accident. With the increased time, the safety measures in your car can work better. We hope you enjoyed this journey through seatbelt safety technologies. Don't forget to buckle your seatbelt. Also, don't forget to subscribe. Thank you.